Welcome. So I would like to solve some problems for you that should be useful for this weekend. So let's start with something relatively easy. So this first problem says that you drive for 1 hour at 60 miles per hour and then drive for 1 hour at 40 miles per hour. What is your average speed for the trip? Well, in these problems, you should know that distance equals rate times time. And if someone asks you to find the average speed, what is that? Well, the average speed is not always the average of the speeds, but the average speed is always the total distance divided by the total time. So if we could just find the total distance and then divide by the total time, we would answer the problem. Well, let's see. We know that for 1 hour, we travel 60 miles per hour for 1 hour. So what is the total distance? Well, distance equals rate times time. So that means that the total distance is the 60 miles per 1 hour times that time, which is just 1 hour. So that's nice. Those cancel. So of course we just traveled 60 miles. In a similar way, if we travel 40 miles per hour for 1 hour, of course we're going to travel 40 miles. So that means that the total distance is just 60 miles in the first hour plus 40 miles in the second hour, and that's over 2 hours. So of course 60 plus 40 is 100, so our answer is 100 divided by 2, or 50 miles per hour. Now in this case, your intuition, and you probably could have gotten this answer correct by just saying, oh, 60 miles per hour, 40 miles per hour, what's the average speed? Let me take the average of 60 plus 40 over 2, which is just, of course, 50. Good. But let me show you that that doesn't always work. So let's look at the next problem. And let's see, what does this problem say? So it says you drive the first half of a 100-mile trip at 60 miles per hour, and then drive the second half at 40 miles per hour. So what does this mean? And then I'm asked to find what is your average speed for this trip. Well, the first half of a 100-mile trip means that I've traveled 50 miles at a speed of 60 miles per hour. And the second half is also 50 miles. But at that second half, I've only traveled 40 miles per hour. So what should your intuition be? Well, it should take longer to travel this 50 miles because I'm going at a slower speed. So let's look, what's the formula again? So distance equals rate times time. So let's use this. And again, I also know that average speed, by definition, is the total distance divided by the total time. Now here, we know what the total distance is, right? The total distance is just 100 miles for the trip. So we need to find the total time. So if I solve this equation for time, distance equals rate times time, so this thing says that time, if I divide r by both sides, is just distance divided by rate. So up here, 50 miles at 60 miles per hour. So that would be, what that implies, and maybe let me call this the first time, T1. That's the time there. So that's a distance of 50 miles divided by distance divided by the rate of 60 miles per hour. So that's just 5/6 of an hour. For the second half, I'll call that T2. That's again 50 miles, but now divided by 40 miles per hour. So that's 5/4 of an hour. All right. Now, if you're not sure that what I'm doing here makes sense, you can always check the units. The distance is miles, the rate's miles per hour, and the time is hours in this case. So sure enough, if you do miles divided by miles per hour, work that out, then the units get you hours. All right, so what's my total time? So my total time is, let me put this here. So the total distance we said is 100 miles. And my total time, let me put it down here. This is 5/6 of an hour plus 5/4. So how would you go about adding that? Well, we could do, you could ask yourself, what's the least common denominator? Well, that's 12. You could get 12 if you did 2 here and 3 here. So in other words, this guy needs a 2 to make it 12. This one needs a 3. So that's just going to be 10/12 plus 5 times 3 is 15/12. So this is 25/12. Okay, great. So my total time then is 25/12 hours. So what is that? So that would be 100. So I'm dividing by fractions, so I flip and multiply, so that's 12/25. And look at that, 100 divided by 25 is 4. 4 times 12 is 48. So this is 48 miles per hour. And look at that. That is not the average of 60 plus 40/2. That's not equal to 50. So in this case, and if you're doing a math counts problem or you're doing an AMC problem, which do you think you're going to get? They're not going to give you this problem that works out to be 50. You're going to get a problem like this that doesn't work out to be 50. So be aware of that. Okay, let's try something a little different. So take a look at this problem. And by the way, so I encourage you, as you're looking at these problems with me, pause the video, try to do the problem yourself, and see if you can do it. And once you've made a good attempt at the problem, then hit the play button and see how I've solved it. All right, so what does this say? Example 1. At Olympic High School, 2/5 of the freshmen and 4/5 of the sophomores took the AMC 10. The number of freshmen and sophomore contestants was the same. Which of the following must be true? There are 5 times as many sophomores as freshmen. That's A. Or B, there are twice as many sophomores as freshmen. There are as many freshmen as sophomores. There are twice as many freshmen as sophomores. There are 5 times as many freshmen as sophomores. So clearly, we need to find some sort of relationship between the number of freshmen and the number of sophomores. So I don't know, let's maybe define a variable. So why not let f equal the number of freshmen, and likewise I'll let s equal the number of sophomores. Okay, so what do I know? 2/5, so if I look up here, 2/5 of the freshmen, so that would be 2/5 of F, right? Took the AMC 10, and it says that 4/5 of the sophomores took the AMC 10. So that's 4/5 of S. The number of freshmen and sophomore contestants was the same. Oh, look, that means that the number of contestants here is equal to the number of contestants here. And there you have it. I have a relationship between the number of freshmen and the number of sophomores. Notice they're both 5. They set the problem up nice for us. They're both 5. So if I multiply both sides by 5, I would just be given that 2 times the number of freshmen equals 4 times the number of sophomores. Or, said another way, the number of freshmen is twice the number of sophomores. There are twice as many freshmen as sophomores. So the answer must be here, D. Okay, so not too bad. Now, you probably didn't have to, for a problem like this, you probably didn't have to actually go about this business of setting variables. So, for example, in this case, you could probably just use numbers. So, suppose you have 100 freshmen. So then you know that 2/5 of the 100, what is that? Well, 100 divided by 5 is 20. So that's 40 freshmen took the AMC 10. You know that number 40 is the same as the number of sophomores. So the number of sophomores that took the AMC 10. So 4/5 of the number of sophomores equals that 40. Now we could solve for S, and what would we get? Well, S would be 40 times 5 over 4, or 50. So there were 100 freshmen to begin with. There are 50 sophomores. So again, we see, let me scroll this. So again, if I had 100 freshmen, 2/5 of them, 40 freshmen, took the AMC 10. And we know that 4/5 of the number of sophomores is equal to the same as the number of freshmen. So that's 40. Now we could solve for the number of sophomores. You get 50 sophomores. So there were 100 freshmen that took it and 50 sophomores. So sure enough, we could see that the number of freshmen is twice the number of sophomores. And we still get D. All right. So let's look at another problem. So this says that Brenda and Sally run in opposite directions on a circular track, starting at diametrically opposite points. So they're completely on the other sides of the track, and they run in opposite directions. So that means they start out, they're running towards each other. Each girl runs at a constant speed. They first meet after Brenda has run 100 meters. They next meet after Sally has run 150 meters past their first meeting point. What is the length of the track in meters? So again, I recommend that you pause at this point, spend at least 5 or 10 minutes thinking about this problem and see what you can come up with. All right. So pause, your last chance to pause. I'm going to start working on the problem. All right. So I like to draw a picture for something like this. So let me see. It's a circular track. So there's my attempt at drawing a circle. They're diametrically opposite. So I don't know, it doesn't really matter. I'm going to say that here's the direction that Brenda is traveling. And we know that after they first meet after 100 meters. So let's say Brenda's going in that direction and she travels 100 meters. Now, Sally started over here and she's gone that far. Now notice that Sally and Brenda together have actually gone halfway around the track. So I'm going to need some notation. How about if I let T1 be the time of the first meeting, And I'll let T2 be the time of the second meeting. And we know that we're going to use distance equals rate times time. So maybe, how about if I let L equal the length of the track? Be tempted to use D, but then I'm going to have different distances here, I think. So I'm just going to let L be the length of the track. I need a rate for these ladies. So how about if I let R, well, let's see, it's Brenda and Sally, but how about R sub B equal Brenda's rate? And now we know they're both constant, so at least the rates don't change. So this is Brenda's rate. We know that this is meters, so probably the rate, we're not really told what that rate is, but it's probably gonna, it's meters probably per something. It could be meters per second, or meters per any unit of time if you wanted to. And likewise, I'm going to let RS equal Sally's rate. Okay, so I know that in the time of their first meeting, now notice the time it takes Brenda to start here, and so we said that we've got Brenda going in this direction and Sally starting here. And the time it takes Brenda to go the 100 meters, Sally has gone all the way to meet her. So that time that it takes for them to meet is the same. So we know that on the one hand, Brenda is nice because Brenda goes 100 meters. So again, I'm using distance equals rate times time. Her distance equals Brenda's rate times T1. Okay, well, what am I trying to do? I'm trying to find the length. So let's get length in there somewhere, the length of the track. Here, they've just gone half the length. So I know that half the length equals the 100 that she goes, Brenda goes, plus the distance that Sally goes, which is Sally's rate times T1. Now, another way that we'll see is also useful. This 100 was, of course, our Brenda's rate times T1 plus Sally's rate times T1, or this said another way is if I use the distributive property and factor out a T1, I would have something like that. Again, not sure how this is going to help me, but let's see. And let's look at the next part of the problem now. So now we're told they next meet. So here they are right here. They next meet after Sally has run. So Sally has run 150 meters past their first meeting point. Well, if she's here and she runs 150 meters, that means she is 50 meters over here, right? That was 100 meters. So Sally, and maybe I'll draw another picture here. So now Sally has gone from here. Sally is 150 meters, still trucking in this direction, right? Now, Brenda was here, and Brenda has gone all the way here, and Sally started there and has gone there. So now they've actually met over here, and they've actually gone the entire length. So now we can say that the entire length is going to be, and by the way, the time that it takes for Sally to start here and go all the way around to get that 150, and the time that it takes Brenda to start from here and go all the way around, that time is the same, and that's what we call T2. That's the time of their second meeting. All right, so now we have the 150 that she goes, plus the rate, so that 150 is salary. Oops, so this is Brenda's rate times T2. But notice that this 150 here, what was that? That was Sally's rate times T2. That's the time that she goes around like that. All right, so notice I've got something similar here. I've got Sally's rate plus Brenda's rate times T2. And now if you look at these two equations, and maybe let's call this equation 1, this equation 2, if I take equation 1, let me scoot this up a little bit. If I do equation 1 divided by equation 2, then on the left-hand side here, I'll have L over 2 divided by L, right? Well, let me actually write that. L over 2 divided by L. And on the right-hand side, I'll have RB plus RS times T1 over RS plus RB times T2. All right. So, and of course, RS plus RB is equal to RB plus RS. These are the same. So this is just T1 over T2. Okay. Oh, so what is L over 2 divided by L? That's times 1 over L. So this is just 1/2. So the L's cancel, right? And so what we just showed is that T1 over T2 is equal to 1/2. Or said another way, T2 is equal to twice T1. Oh, well, that makes sense, right? Because here in T1, they're covering half of the track. And in T2, that's the time that it takes them to basically cover the entire track. So it makes some sense that T2 should actually be twice T1. They're both going at a constant rate. So their combined rates are the same. All right. Well, can we use any of this? Again, we're trying to get L, and I have two different equations here with L. Oh, but look, I have a third equation here. I've got this 100 here. So let's look at equation 2, and let me scoot up and get some room. So I've got that L equals 150 plus the rate of Brenda times T2, but now I know that the rate is the rate of Brenda times 2T1. But up here, the rate of Brenda times T1 was 100. So the rate of Brenda times T1 is 100. And now I got it. So this is 150 plus 2 times the rate of Brenda times T1, which is times 100. So I get 150 plus 200, which is 350 meters. And there's your answer. Okay. So again, not, I don't think, a horrible problem for you. Again, for me, I think it's very useful to sketch some sort of picture to do a problem like this. All right, let's do one more of these sorts of rate problems that are at a math counts or AMC level. So let's look at this example. It says Andy's lawn has twice as much area as Beth's lawn and 3 times as much area as Carlos's lawn. Carlos's lawnmower cuts half as fast as Beth's mower and 1/3 as fast as Andy's mower. They all start to mow their lawns at the same time. Who will finish first? Okay, so I've got relationships between area and relationships between the mowers. Again, I suggest you, at this point, pause and give this a go. I would suggest you want to think of it, this is like a distance equals rate times time problem, but instead of your rate being distance divided by time, now your rate is how much area that you cut per time. And so, and then what I suggest, if you want a hint, I suggest that you think of this in terms of, since you're asked who will finish first, find out maybe solve your rate for time, put all the times on the same basis in some way. All right, so pause it, try this, and then come back. Okay, so you're back. One of the things, because this problem talks about area, I want to use some notation. So you may have seen before notation like if I have a triangle ABC, then one notation that's common that I like for area is putting things in brackets like that. So I kind of like that notation. So I think what I'm going to do is say, since I'm talking about Andy's lawn and the area of his lawn, so I'm going to say maybe bracket A is the area of Andy's lawn. And likewise, I'll refer to the area of Beth's lawn and the area of Carlos's lawn. And then they also have rates, so maybe I'll let RA equal the rate of Andy's lawnmower. Right? And, well, what is that rate? Well, it's going to be in some sort of area, whatever your favorite, it's lawn, so it'd probably be natural to talk about acres as a measure of area. It could be, I'm just going to say it is lawnmower, that rate is units of area per time, whatever that is. I don't think it's going to be necessary to actually specify that, but let's see how it goes. And of course, just like up here, I'm going to refer to the rate of Beth's lawnmower and the rate of Carlos's lawnmower. Now let's try to translate all of this. And here, for instance, what does this all mean? If TA equals time for Andy to cut his lawn, then I'm assuming here that the total area that Andy cuts is the rate that his lawnmower, so this is kind of like my distance equals my rate times my time. Right? So that's the kind of relationship I'm working on here. So now let's translate what they tell us. So Andy's lawn has twice as much area as Beth's lawn. So let's maybe put that over here. So Andy's lawn has twice as much area as Beth's lawn. Okay, great. What else do we know? Andy's lawn also has 3 times as much area as Carlos' lawn. Okay. So 3 times as much area as Carlos's lawn. Now, Carlos's lawnmower cuts half as fast as Beth's lawnmower. So the rate that Carlos's lawnmower cuts is half as fast as the rate of Beth's lawnmower. And Carlos's lawnmower is 1/3 as fast as Andy's lawnmower. Okay, they all start to mow their lawns at the same time. Who will finish first? Well, I think we should just compute the different times. So we know that the time that takes Andy is the area that it takes Andy divided by Andy's rate, right? Just looking at this equation. Let's translate. It looks like we've got Andy in terms of Carlos, and we can solve this rate for Carlos. So let's just translate everything into Carlos. So let's see. So Andy's area, his yard is 3 times bigger than Carlos's yard from here. Let's see. I need Andy's rate. So here it is over here. I can multiply by 3. So Andy's rate is 3 times Carlos's rate. Oh, look at that. The 3's cancel. So this is just the area of Carlos divided by Carlos's rate, which is the same as the time of Carlos's. So they finish at the same time. Now, if I haven't made a mistake, it seems as though the answer should be Beth, but let's verify that. So let's compute time of Beth's. We know that Beth's time is what? Well, it is her area divided by her rate. Okay, let's see. What do we know about? Well, here's one thing. It looks like Beth's area is half of Andy's. Okay. And Beth's rate is twice Carlos's. Okay. Well, let's see. I compared to Carlos up here. Oh, I know that A is 3 times from here, right? So let's just substitute. So this is 1/2 times 3 times Carlos's area all over 2 times Carlos's rate. So this simplifies, and this is just 3 over 2 times 1/2, or 3/4 Carlos's rate, or Carlos's area divided by the rate, which is 3/4 the time of Carlos. And sure enough, Beth's time to finish, right, the time to cut her lawn is 3/4 Carlos, which is 3/4 that. So Beth is going to be the person that finishes first. All right, so hopefully you find this useful. We will, this coming weekend, solve problems like this. So hopefully these techniques have been useful to you. All right, thanks for watching, and I'll see you later.